start recording. So yeah, as I suggested in last session, we will start from beginner levels. So this is the first class of beginner levels where we are gonna flash our own flight controller. So let me show you. Yeah. The camera is visible for you. Hand raise. You can write in chat if you want. I think it's visible. Okay, thumbs up. So yeah, first the hardware we're gonna use is this. If how you can see, yeah, this is a STM32F411, which is our main computer, and the second thing is the IMU. This is MPU 650. It is a I2C based IMU. If you're gonna build your own drone, I won't suggest you use this one because it's based on I2C, and I won't recommend you use I2C type IMU for your drone. I'm using this because I have only this, and the cost of these is 280 roughly for STM32 and 120 for MPU 6050. And if you are gonna use SPI based IMU, which is MPU 6500, it's gonna cost you around 300 or 350. So these are the sorry, these are the hardware we're gonna use. Provide link. Let me show you. This is the main chip STM32, which you can bought from Robo, and the other thing was MPU 6050. This is MPU 6050, but I won't recommend you use this one if you're gonna build. I suggest you use this one. This is the MPU 6500. So you can buy from here. Okay, this. Any question related to hardware? And is my voice clear? Anything out of place? Let me know. Yeah, these are the hardware part. Let me show you the software we are going to use. First, the firmware we are going to use is as this is a beginner level, we will using this pre-made firmware from you can read the name. And the software we're gonna use, someone wants, the settings wait. Okay, the software we're gonna use, the firmware is this one, and the software we're gonna use is iNav configurator. You can just go here and go down, go to assets, and you can download it from here, whichever you have, Mac, Linux, Windows. You can download it from here. Download the iNav configurator, install it. That's one part. The second is download this file. I might as well download. I think I have this or not. I don't know. I have too many things. This one, yeah, I think this one I have it already installed. So yeah. So these are things you need for the software part. And you can use, and this is a pretty good open source. You can just go here and you can find all the things you need from here. The wiring diagram, the wiring configuration, everything you can find here. As this is a beginner class, we won't go too deep into this. So the next part is wiring. And yeah, this is the wiring. Let me just change this. Yeah, I hope you can see the video and the screen at the same time. You can just go to robo.in. You can just search for STM32 and MPU 6500 or 650, whichever you like. So I don't think there's any need for me to paste links here. Okay, where we were. Yeah. So for the wiring, we will use black, red. The camera quality, I think, is pretty going down. Now it's working fine. OBS has some issue, I think. I will just down. I think the video is pretty laggy. I don't know why. Whatever. I will think about later. So the wiring goes as it's seen here. If I can show you, I don't think I can. Nope. If you can see here, it's written VCC, ground, SCL, SDA, which are I2C pins. So you just need to connect them like shown in this picture. You need to connect VCC to 3.3 volt, which is 3v3, ground to ground, SDA to SDA, and SCL to SCL. So let me connect them quickly. Go VCC to 3 volt, ground to ground, and the first one we have is SCL, and SCL goes to here, SDA to SDA. So the wiring part is done. Now we will fire up the iNav. Oh, one more thing. If you can go here, like here, you can see INAV 7.0.10, INAV 7.1.0, and INAV 8.0.0. You need to keep these number in mind as the मौसी आवाज आ रही है. Sorry for the disturbance. So where we were, yeah, as I was saying, you need to keep in mind the version you are using. Like INAV 7.0.0 firmware only works with INAV. Where was it? I think like here, it's 8.0.0. It will only work with INAV 8.0.0. So keep that in mind. If you download 8.0, you also need to download the same version of configurator. So yeah, so let me open, and the one I'm using is INAV 8.0. So this is the INAV configurator. I hope you can see the camera is going. I think it's camera is dying, I think. Whatever. Let us connect our laptop to the iNav. I think it's working the best this way. Not too much lag, I think, right now. I might have pop it. Yeah, now I think you can see it clearly. We have connected our STM32 to the laptop, and the first time you boot it, like right now we are uploading the firmware, you need to hold down the boot button. If you can see here, there's two buttons, the reset button, the boot button. You need to press the boot button. Yeah, it's showing. Now if you can see above, it's gone into DFU mode. You need to put this board into DFU mode to flash it with a firmware. So now that we have it in DFU mode, we can flash the firmware. Not connect, but firmware flash. We will load custom local firmware, and we have put it desktop. Where was it? Yeah, as you can see here, it is configurator 8.0.0. We will choose it accordingly. So 5.1, 6.0, 7.1, and we have 8.0. So we will select this, open it, flash the firmware, and we will wait. If anyone has any question, they can ask or write in the chat box. And it's the firmware is flashed, so now we can, I think, connect. Yeah, we connected. And this is a very important step. If you are in this screen, don't click any of these, just keep current setting, not recommended, click on this one. Yeah, if you can see, we can now, yeah, it's working. You have successfully flashed the iNav firmware into your STM32 board. So now we will calibrate it. As you can see, it's a block type of thing. We need a drone in this place. So we'll go into, first we will go into mixer. Yeah. So first we'll go into the mixer setting, where we will select what type of drone we're making. It's a quadcopter, tricopter, bicopter, hexacopter. We need to configure it here. The one we are building is quad X, which is already selected. We will load and apply, save and reboot. We will wait. And if we go to status, now we have a drone. You can see it's working. Now the next thing is motors. We didn't connect motor yet, but we can just configure it here. Just enable motors. If you're using standard motors, select standard, but cheap motors also support 1 shot 1 to 5. You can select this. Other than that, leave these as they are. Save and reboot. If anyone has any question, they can ask. In the port section, here we will basically configure things like GPS, your RC link, telemetry, things like that, which we haven't connected yet because this is a first class where we'll only calibrate flash the app's flight controller, so we will leave it. In the configuration section, we'll configure what IMU we are using, what magnetometer we are using, basically a compass, what barometer we are using for altitude. Potato, we won't be using this because it's mostly for RC planes and it's pretty expensive. It's used for airspeed measurement. The next is rangefinder. We will be using it in the future classes. It's basically a LiDAR, or you can say sonar, whichever we're gonna use. Optical flow is also out of our syllabus, if you say so. Also the I2C speed, you can increase it to 800 kilohertz. Other than that, you can configure your voltage, battery settings and things like that. If you have these things, only then. We will covering one by one, so you can leave these as it is for now. The next thing we're gonna do is calibration. We need to calibrate our gyroscope. If I can show you, it's laying flat right now, but it's not flat. If you can see, it's a little bit tilted, so we will fix that. As I only have this, so it won't be proper calibration, but just to show. Also up here you can see what sensors we have and what we don't have. The blue means the sensor is registered and it's working. The red means the sensors are selected but they are not working, not connected, whatever. And the gray one is we didn't enable them, simply. So let us go back to the configuration, calibrate. So to calibrate your drone, we will just correct on calibrate. Now we'll okay. We need to hold the drone in these 6 positions. So first flat, press calibrate. As you can see, we got a tick mark. Then side, calibrate, calibrate. Wait a second. And now this processing. This side, this side, upside down. This side. And the calibration is done. Just okay, save and reboot. Always save and reboot after you do these types of things. Okay. Our gyro is calibrated now. Now if we go here, go here, if I place it, yeah, now you can see it's flat. I will just my wire is tangling it. Wait a second. If I can show, yeah, now it's calibrated. So we'll go on. So this is how you calibrate your gyroscope, and as you can see we have some red marker above. Let me fix those. Put 800, save and reboot. And the I will say none. So yeah, we have successfully calibrated our gyroscope. So other than that, this is the first class, so we will only cover the calibration and connection. So you have a basically you have a working flight controller. As this is a beginner class, you can, as we have used this, you can go to this page and you can read it. You can see, find all the connection and everything here. Like if I can show you this, open, I made a new tab. I don't think, let me just, I think I have saved these somewhere. I might as well just change this to screen only, better for I don't know why it's, yeah, it's open now. So you can see here all the wiring, like 3.3 volt ground, 5 volt SDN SCL for the I2C communication. For these are motors S1, S2, S3, S4, S5, S6, S7, S8. So you can basically connect motors and servos here. Servos for like gimbal and things like that, you can connect servo here. Then we have RxTX for GPS, LED pin, MOSI, MISO, SCL, NSS for SPI communication. Then also this side we have 5 volt ground, 3.3 volt, another motor slash servo, motor servo, and the A3 and A2 are another UART port for your RC link. Again 2 more motor ports, or you can say servo port, and this. So these are the connection. Keep it there. Let me see. So this concludes our first class, which is a pretty basic class. So if you have any question, you can ask me. Any question regarding iNav configurator, the firmware we are used, and things like that. If you don't want to ask, you can also type in the comment section. I will read them. The main difference between the Betaflight and iNav is in iNav you can use more sensors. Basically for navigation and things like that, you have more option compared to Betaflight. Betaflight is basically for racers and simple drones where you need latency and things like that. In iNav you have many things related to navigation, like long range. Basically Betaflight you don't really do long range in Betaflight. For long range you need iNav or better AutoPilot, but AutoPilot is pretty difficult, so mostly use iNav. If I can, let me just, if I have the option, I might be able to show you this. Yeah, if you can see here, this is iNav's mission control. What it basically does, you can set if I can zoom in, that might be a this point 2, like you select this point. I want to go from here to here. This is just an example, don't take it seriously. That's too long range, too much. So you can set points like this, and this, and you can save it. Then you can go to where, in modes panel, you can assign a specific switch, and the way it works is you flip this switch and the drone will follow these paths which you have preloaded it with. So this is the main difference between iNav and Betaflight. Also in here you can see we have pretty much more sensors. any other question? Anyone? Any question? It depends what type of drone you are making. If it's a racer type 5-inch drone, you will need 4S, 5S, 6S with a pretty high C rating. C rating basically discharge, how much current it can discharge given a moment. Yeah, it will depend. If you are building something like what can I say, 10-inch drone, then you won't be needing a pretty high C rating, as you won't be needing that. and you need, for 10-inch drone you need a bigger capacity battery, like 4000, 5000, 6000 mAh battery. So it will depend very much, like what type of drone you are building, what your need is. You are using you are building a long range drone or a racer, and things like that. It also depends what type of battery you need. Like if you need a high C rating battery, you usually go with lipo battery. If you need a high capacity battery with less C rating, you can go with lithium ion batteries. Like if I can show you this one, I think, yeah, the one I am using is moly cell. This. Like in my drone I am using these cells, three of these to be specific, as they are pretty high capacity, 4500 mAh, and they are pretty basic 10C rating, which basically mean 4.5 amp into 10, and you get 45 amps of peak current. I might as well cut this. So yeah, these are cells I'm using. If you are hearing background noises, you can ignore them. So if you are building a drone, always know the max discharge current, which is 45 amps in this case. If you purchase a battery with pretty low C rating, your drone won't lift. So keep that in mind. Any other question? Can we get a session where we can learn how to choose motors? By the way, different KVs, do's and don'ts. Huh. I think we can do a session about components of drone where we'll also cover motors. KV. So KV basically means, um, like for example, like we have. Let me show you. Where is this? Yeah. Like for example, we take a 1000 kV BLDC motor. So people generally use these types of motors. Yeah, you can see 1000 kV. So the 1000 kV basically means at a given voltage what type of RPM it will put out. Like if you connect, let me give you a calculator so you can see. Like we have a 1000 kV motor and we have a 3S battery. 3S means let me just the battery's peak voltage is 4.2 and we have 3S, so that will be 12.6 volt. So these are the highest volt your battery can put out, and we'll multiply it by the kV rating of your motor, and you will give this is the maximum RPM it can give with a 3S battery. So this is the mainly what kV means. And if you ask me for do's and don'ts about kV, like if you are building a 10-inch drone or like a bigger drone, use a lesser kV motor. And if you are building a racer drone like 5-inch, 4-inch, 3-inch like this, use a higher kV motor. Usually the kV rating for 5-inch drone is between 2200 to 2400 kV. Any other question you want to ask related to kV? uh, any specific doubt? Because I can't think of things about kV right now which you need to consider. Also consider the amp your motor gonna consume and the amps that the battery gonna provide, because if you choose a ESC with a lower amps than the rated amps for the battery, or what can I say, not battery, the motor, your ESC will burn. So keep that in mind. Like for example, if your ESC is 30 amp, your motor is rated for 40 amps, your ESC gonna burn. Any other question? Might as well disconnect it. I think there was a person who was asking question in the group chat, Rakesh or something like that. Is he still here or he left? I think he left. Any other question?
रोटी खा जा रोटी रोटी खा जा रोटी खा जा रोटी अभी हाँ अब कितना तो खाना ना
I think yes, it's recording. Can I use NRF24L1 with antenna? I use it for transmitter and receiver. Yeah, you can. I think I might as well release a new course after this about a DIY transmitter receiver with NRF24L1, where you will learn how to connect it, what to do and don'ts, how to program buttons like push button, dongles, rotary switch, and potentiometer. These types of switches, how to use them, how to configure them, and I might also add how to connect them to a OLED screen. Like what button you press and what you done, it will show on a screen. So you will get a basically a UI thing for your transmitter receiver. So I might add this course after this one, but it's not confirmed, so let's just say I have planned it, but it will work or not, I can't say for sure. But yeah, you can definitely use NRF24L01. What time is it? 7:46. I will just keep it on for 5 to 7 minutes, and then we will close this, wrap up the class after 5 7 minutes. Any more question? You can open your mic and ask also. DIY transmitter or ready-made transmitter, which is of more value if we are in a tight budget? See, if what can I say? If you want to make a transmitter receiver yourself, you can definitely made it yourself. If you don't need something hi-fi or anything like that, a basic transmitter with a basic range, if I say so, it's better to go with a DIY route, like using a NRF24 aluminum, something like that. If you don't need a long range or something like hi-fi thing, then you can go with the DIY version. Because if you want to buy a ready, again we will go to robo.in and we will just this site is too, too slow. Drone transmitter receivers, and if we forget, if you can see these things, they are pretty expensive and they are pretty outdated also. These things are pretty outdated. If you ever want to purchase a ready-made transmitter, then I suggest you at least buy something like this. But if your budget doesn't allow something like this, then I suggest you use you make your own transmitter and receiver. If you don't need something hi-fi, make your own and it will work fine, I can say this. But if you need something like you are doing something very precise, you need latency at a minimum, then you need to go for a ready-made. If you doing something very, what can I say, precise. If you're not doing anything precise or complicated, then you use a DIY transmitter receiver. That works. That works pretty well, if you ask me. Like if you're not building a drone or something, you're building a car or something like a bot or something like that, then it's recommended you use NRF 24L1 type transmitter receiver, which you make yourself. Those works the best. I think that's enough for today's class. If no one has any question, we can end this class. Okay, okay, Nitesh. In DIY transmitter, it is hard to rectify any errors or range issues. Hmm. In DIY transmitter, there is not any error thing. It's mostly a range thing, like with likewise. Like let me show you. NRF24L1. I won't show like this, and if I can NRF bytes NRF. Um, it just didn't want to work. I don't know why. If I can show you. I scratch that. Let me see. Like this one. This is a NRF 24L1 without an antenna. So this will give you a less range. And there's also another version with a longer antenna. Yeah, this one. This will give you a longer range. I think it's tested for, I think, what, 600 to 700 meter. It's line of sight range. So yeah, that's the range you're gonna get. But if you use something like ELRS type transmitter receiver, range. So if you use this one, then you will get a range like, where can I say, yeah, range like these. If you can see, 101 kilometer, 43 kilometer, 40 kilometer, 35 kilometer, 20 kilometer. These types of range you can get using ELRS type receivers. And you can also find videos regarding this. If you want to go, you can just search ELRS and you will find these. So these are basically the main difference between the DIY and commercial transmitter receivers. And as far as the error goes, I don't think there's any error issues as, as far as I know. The error thing only occurs when you exceed the range, or the line of sight is not line of sight and there's some trees, walls and something like this, and the packet breaks. That's the main issue between this is the main issue with the DIY transmitter and receiver things. But for, if you, like I said, if you don't need to, if you don't want to do anything fancy with your drone or bot, you can build your DIY version. But if you want to do something fancy like a 100 kilometer, 40 kilometer, 50 kilometer range flight or whatever, then you will need a commercial transmitter receivers. I think that's good enough for today. Anyone any more question? I think the time is up. Oh, okay guys, I think that's enough for today. We'll meet in the next session, which will be most likely what can I say, next to next Monday or something like that, because I'm busy this week. So we will be doing class next to next Monday or something like that. Okay guys, bye.